Hi students, in this chapter we will be looking at the separation techniques. So these separation techniques will be used to separate mixtures. So separating mixtures, we can actually group the mixtures according to their states. So for example, we can have solid mixtures, we can have solid liquid mixtures, and then we can have liquid mixtures. Okay, so the first few examples we are going to look at, this three that I just take, will be mainly the solid liquid mixtures. Okay, for solid liquid mixtures, we can actually separate insoluble solid from liquid by filtration. Okay, so filtration is the method to separate insoluble solid from the liquid. Okay, the logic or the rationale behind why it works is solids that are too big to pass through the pores of the filter paper will be stuck on the filter paper as residue. The solvent, which is usually pretty small, like the water molecules are usually very small, and then they are small enough they can pass through the filter paper. Okay, and then that's how we separate the insoluble solid from the solvent. Okay, so picture wise, we must know how to draw. Over here, draw your filter funnel collected using a conical flask, and then you pour the mixture through the filter funnel, and then be able to identify, right, the insoluble solid that's trapped on the filter paper is called the residue, and then the solvent that flow through will be the filtrate. Okay, the next one that we are going to look at will be the soluble solid plus liquid. Okay, so soluble solid plus liquid, right? We can use two methods. The first method is called evaporation to dryness. So evaporation to dryness, essentially what is it? Is I heat until all the liquid or all the solvent evaporate away. Okay, and then this one can be used to recover solutes that are heat stable. Heat stable means usually they have high melting point, high boiling point. Okay, high melting point, high boiling point. When I say high, the melting point, boiling point could be about 1000 degrees and above. Okay, so high melting point, high boiling points, why? They do not decompose upon heating. So if I use a Bunsen burner to heat it, the heat could reach up to 400-500 degrees Celsius. So if your melting point is much higher, when I heat the mixture, right, the water, for example, which is the solvent, right, will boil or turn into water vapor at 100 degrees Celsius, right? The solute that has high melting point, high boiling point does not change state, so it will be left behind as crystals. So this method is called evaporation to dryness, where I heat until all the water is gone. Okay, as a rule of thumb, please know that your heat stable solids are the group 1 salt. So you see sodium chloride, sodium nitrate, potassium chloride, potassium nitrate. These are all heat soluble solutes. Okay, soluble impurities present will be deposited together with the required solid. Okay, so if your mixture is not made from one solute, right, then you will have some impurities, and these impurities will be found. Okay, so usually the experimental setup, we will set it up using an evaporating dish, and then we heat until all your water is gone, all the solvent is gone. Repeat, this is for heat stable. Okay, so for example, if the substance is not heat stable over here, and then you try to heat it, right, it will turn black. When it turns black, this one, they decompose. So when they decompose means their melting point is pretty low, and then it will break down into the simpler elements or the simpler compounds. So when you heat it, you cannot heat until all your water is gone because the solid is not heat stable. So if the solid is not heat stable, what we have to do? We have to do crystallization. Okay, so crystallization is we use it for solid that is heat labile. So labile basically just means it is not heat stable, means it is low melting point, low boiling point. Okay, this one, same thing, the solid is still soluble, because not soluble we use filtration over here. Okay, solid is still soluble, but it is not heat stable. So when I heat, I don't heat until all the water is gone, I don't evaporate to dryness, I heat until saturated solution. Okay, saturated, recall, this one is maximum amount of solute. Okay, it is the maximum amount of solute. Okay, so you heat until saturated solution, so there is a lot of water is being evaporated away, but there is still some liquid left, and then it is saturated, and then you cool the saturated solutions, your crystals will form. Okay, this one is used for heat labile solid, which will decompose upon heating. So common examples of heat labile, any solid that you don't see that's not under the group 1. So common examples, we have sugar, glucose, C6H12O6, or copper 2 sulfate. Okay, this is the common blue color reagent that you're using in the lab. Okay, so this sugar and your copper 2 sulfate will actually decompose upon strong heating. So we heat until saturated solution. Okay, so these pictures over here shows heating until saturated solution. Alright, so same thing, I use a evaporating dish to heat it. Okay, I use an evaporating dish to heat it, but I heat until this is saturated. So most of the water is gone, and then there's a little bit of the solvent that is left. Okay, and then cool this, crystals will form automatically. Okay, how do I know that this one is saturated already? So to test for saturation, you add in a glass rod over here. If you add in a glass rod and then you take it out immediately, right, you see some crystals form along the glass rod, means it is already a saturated solution. Okay, crystals will form along the glass rod. Yeah, it is already saturated. Okay, you can also use a water bath to heat solution as opposed to direct heating. Okay, so some of the solvent, for example, if I use ethanol as a solvent, which is an alcohol is what we call volatile liquid, and then they are actually pretty flammable. So I don't heat the ethanol directly. I heat using a water bath, which is like a beaker. Okay, a beaker, right? And then your usual tripod stand and all that, and then your Bunsen burner, and then you heat the solution or the mixture with ethanol. Okay, so you heat this water bath, right? This water bath, the water vapor that is being created or boiled will actually be used to heat your ethanol. Okay, same thing actually, once your water bath is boiling, right, it's better if you off the Bunsen burner and just use whatever heat over here to heat the ethanol, to heat it until it is saturated. Okay, so we have looked at how do we separate the solid liquid mixture, right? Under the solid liquid mixture, we have either whether your solid is soluble. If it's soluble and it is heat stable, we evaporate to dryness. If it is not heat stable, we heat to saturated solution. If your solid is insoluble, alright, we use filtration because the particles are too big to pass through the pores of your filter paper, and then they will be trapped on the filter paper as residue. Okay, so next thing that we are going to look at will be more of your solid mixtures over here. Okay, solid mixtures over here.